Hi everyone, it's Professor McBain. Welcome back to Chem 100 and welcome back to our lecture series on water purification methods. This video is going to cover filtration and reverse osmosis. Alright, welcome back to our lecture series on water purification methods. In this video we're going to be talking about filtration and reverse osmosis. So filtration is a pretty simple process to understand. Really all that's going on here is that you've got some sort of physical barrier that's keeping your contaminants from getting through to your container that has your purified water in it, okay? And so these physical barriers, they might just have different pore sizes, okay? So this ceramic filter just happens to have very, very small pores that parasites can't get through and dirt can't get through and other things like that. Now, stage 2 and stage 3 are really where we have the chemical stuff going on. Okay, so activated carbon tends to attract stuff like, organic chemicals that are all made of carbon, but it also tends to attract chlorine, all right? So the stage 2 filter will attract organic contaminants and chlorine, and it will just make them like, they're stuck on that filter level, okay? And then this heavy metal reducing media, there's basically a little electric charge that's going through here, I believe. And so if you have some heavy metal ions that meet up with the heavy metal reducing media, well, it basically causes those metal ions to go from being dissolved in water to all of a sudden they are solid metallic form, okay? And so then again, they'll just get stuck on this filter, okay? And so many refrigerator filters have 3 systems just like this. So you've got the fibers, which, I mean, it's a little bit like the ceramic filter. It's just like particulate matter, catching the particulate matters. The charcoal, that's really the activated carbon. And again, it catches organic impurities and chlorine. And then you might also even have an ion exchange filter in your refrigerator system that can lower the water hardness and again catch those heavy metals. So, but the thing with refrigerator filter systems is that they're efficient at capturing small amounts of these impurities, and your refrigerator manufacturer is going to assume that your municipal water system is already meeting the MCLs set by the EPA. The problem with any filtration process, whether we're talking about like water purification or even just like a coffee filter, is that large quantities will pass through to the consumer, especially because a filter might just eventually get saturated, okay? So filters are a lot like sponges. They're not exactly like sponges, but they can get saturated, and that's when the contaminants are going to pass over and behind the filter and then get back through to your water. Another nasty thing that can happen is that if you let your filters sit for too long without cleaning them properly, then a thin layer of bacteria will grow on the outside and the bottom edge of the filter. They call that a biofilm, all right? And so your water might be purified of impurities, but then it gets a nice little jolt of additional bacteria right as soon as it goes into your clean receiving container. Isn't that disgusting? Yeah, so anyway, those are the main cons of filtration, okay? And so if you suspect that your water has a significant concentration of a hazardous impurity that's above the EPA's maximum concentration limits, then you would need a very, very large filtration system in order to handle it, okay? And then you would also want to perform some post-filtration testing just to make sure that you actually have removed those unsafe levels of your contaminant of interest, all right? One of the most common brands of filters these days tends to be Brita filters, and they actually offer this convenient comparison between, you know, what their faucet filter can do, what their pitcher can get rid of, what their dispenser can get rid of, and so on. And so you can see that the faucet one gets rid of a lot of stuff, but it doesn't do too well with mercury, cadmium, or copper, whereas the pitcher does pretty well with copper, cadmium, and mercury, but then it doesn't do too well with lead, asbestos, and so on. And so you can already see that you would need to use the faucet in tandem with the pitcher in order to eliminate all of them. Now, that said, This is just a really nice diagram, and it doesn't state any specific concentrations that their filters can handle very well, or filtrations over time or anything like that. I wouldn't trust this to get rid of, again, like very, very, very high levels of these contaminants. All right, so it's always a good idea to do post-filtration testing if you're really concerned about that. Okay, I think that that's all that we're going to talk about with filtration. So let's move on to reverse osmosis. Now, before I can talk about reverse osmosis, first we need to talk about what osmosis even is. Okay, so this is your before picture with osmosis. You've got some sample of water, and there is a semi-permeable membrane that is dividing your sample between some pure-ish water, or at least less concentrated water. On the other side of this membrane, there's a very high concentration of salt in that water. Now, what will happen all on its own is that the water is going to gradually go through the pores of this semi-permeable membrane, and it's going to cause the salt water side to become more dilute, and it's going to cause the less concentrated water side to become more concentrated. Okay, and again, it does this just all on its own. You don't need to have any sort of source of energy or even gravity to do this. It's just it's something that just naturally happens in the world. Everything is trying to move towards equal concentrations on two sides of a barrier. Okay, so that's regular osmosis. In reverse osmosis, the idea is that you are trying to force all of that to happen backwards the other way. So you're starting off with a higher amount of that concentrated solution and a fairly low amount of that less concentrated, like, water side. And this has some what we call osmotic pressure. Now, if you apply pressure to this side, then you can force the solution through, right? And it would really be that you're forcing the water molecules through this semi-permeable membrane it has pores large enough to let water molecules through, but they're small enough that whatever contaminant you're trying to keep on this side, it can't pass through. Okay, so you just apply pressure, and then gradually you get more and more and more water. Okay, so that's reverse osmosis. Now, being a reverse of a natural process, this requires a fairly large amount of energy because you have to apply that hydrostatic pressure on that side. Okay, but reverse osmosis is pretty great because it gets rid of a lot of things, including benzene. And so as a result, a lot of rebuilt paradise homes are being fitted with reverse osmosis pumps. And then, of course, they're having their filtered water tested for benzene, and they're seeing that, there's no benzene in their water if it passes through an RO system. There are a lot of people that are also just installing reverse osmosis systems in their homes for other reasons, like for peace of mind. Anyway, you might use reverse osmosis for a variety of reasons. Let's take another look at those membranes, okay? I like this graphic a lot because it basically shows you that this membrane, it's small enough to, again, allow these small water molecules through. These are the white ones here. But larger things like ammonium compounds and potassium and fluoride and magnesium and calcium, and then even larger things like viruses and bacteria, and then, of course, like other parasites would, of course, be much larger than bacteria. All of these things are actually like too large to fit through this membrane, but water can fit through just fine. So one of the disadvantages of reverse osmosis is, of course, that if you have something that is smaller than water, like physically smaller than water, it's also going to pass through this membrane. So as long as your contaminant is not smaller than water molecule, then it'll stay behind. But anything smaller than water, it's going to be stuck there in your so-called purified water. And one of the other disadvantages of reverse osmosis is that, of course, it's another energy consuming process. It doesn't take nearly as much energy as distillation, but it requires some in order to maintain, again, that hydrostatic pressure. So it is another energy intensive process. It also isn't super efficient. There is a limit to how many water molecules you can reasonably push through before it starts becoming a big issue of practicality of how much hydrostatic pressure you can be applying, okay? So you have what they call leftover brine that never gets purified. There's only so much water that you can actually purify. One of the last disadvantages of reverse osmosis involves this semi-permeable membrane right here, okay? When you're first starting to use your RO system, you have to chemically treat your membrane with some chemicals that will basically extend the life of the membrane. And even then, eventually these membranes may rupture, okay? Kind of like a, filter may rupture as well. And so these membranes have to be replaced, and so that's another expense that, that gets passed on to the consumer, of course. So this isn't just a system that you can use over and over and over again. It has some parts that need replacing every so often. There are a couple of places throughout the world that use reverse osmosis for obtaining municipal drinking water as well. I guess one of the bigger ones is the RO plant in Sand City, California, and it produces about 250,000 gallons per day just from this large-scale reverse osmosis procedure. Hedera's seawater reverse osmosis plant is another one. It's a much larger one, and it again takes salt water from the Mediterranean Sea, and again it pushes it through an RO system, a very, very large RO system, and it produces 120 million gallons of fresh water every day. And in its plant here, it's got 50,000 or more membrane units, right? And so replacing those must be very expensive. And yet the city of Hedera has decided that replacing the units is better than having to, move the entire city to somewhere else, right? The people are well established in this location and so on. So again, here's another breakdown of the issues of reverse osmosis. You need energy to maintain that water pressure. The membranes need to be replaced. You also need to pre-treat the membranes in order to extend their life. And then again, there's that output brine that that you can't ever purify. The other issue with that output brine that you can't ever purify is that it's got to go somewhere, right? There's always an issue of disposing the waste, just like we saw a few weeks ago with nuclear power and all of that. So usually where that brine goes is that it's just usually released into the ocean or the sea or into nearby lakes or just into the ground. And with these high concentrations of salt, these unnaturally high concentrations of salt, it can be hazardous to the plant and animal life. So yes, eventually it gets diluted if you're dumping it into the ocean, but right where it's dumped locally, it starts out more concentrated, and whatever's living right there at the dump site probably isn't living anymore. All right, so what should you be taking away from this lecture? You should be taking away that there are quite a few different ways to purify water, and these are just a couple of them. A lot of these water purification methods tend to be used in tandem with each other. You should also be looking back and trying to pay attention to what kinds of things can actually get taken out from each of these water purification methods and what can't be taken out, all right? And so I leave that to you to go back and sort through, but I recommend that you come up with a table of like, what can it take out, what can't it take out, what are the advantages, what are the disadvantages, and so on, okay? All right, thanks for joining me for this lecture series on water purification.